Good day all, I am Dr. Paul. Today I'll be talking about the ion-electron method of balancing redox equations. You recall that when chlorine is bubbled into aqueous ion salt, aqueous ion 3 chloride is obtained according to the reaction shown below. That is ion 2 ion plus chlorine gas to give you ion 3 ion plus chloride ion. Then assign each of the atoms an oxidation number. So if you look at ion 2 is plus 2, chlorine is 0, ion 3 is plus 3, and then chloride ion is minus 1. The next step is to separate the equation into an oxidation half and a reduction half, as can be shown in the slide. For the oxidation half, ion 2 is moving to ion 3. That means oxidation number has increased from plus 2 to plus 3. While for the reduction half, chlorine is moving to chloride. That means oxidation number has decreased from 0 to minus 1. Chlorine has an oxidation state of 0 because it's a neutral atom, while chloride is carrying a charge of minus 1, an oxidation number of what? Minus 1. Now check if the atoms in each half are balanced according to the law of conservation of mass or conservation of matter. So for oxidation half, from ion 2 to ion 3, the atoms are what? Balanced. We'll have each atom of ion. For reduction half, the atoms are not balanced because chlorine is carrying what? 2 atoms, while chloride ion is just 1. So recall that a molecule of chlorine produces 2 chloride ions. So to balance the equation, you add 2 to the chloride ion. Now you can see that the equation is balanced. You have 2 molecules or atoms of chlorine and then 2 molecules of chloride ion. So it is balanced. Next is to balance the charges. The number of electrons lost must equal that of the electrons gained. So for oxidation half, ion 2 is moving to ion 3, meaning it involves a loss of electron. Difference in oxidation number of ion is plus 1. Therefore, there is a loss of 1 electron. So you add 1 electron to the right hand side to balance the charges, and making the oxidation half to become ion 2 to ion 3 plus an electron. So the charges are now balanced. Remember that a positive sign means loss of electron, while a negative sign means gain of electron. So for the reduction half, it involves gain of electron. Considering the change in oxidation number of chlorine, which is minus 1, meaning a gain of 1 electron, but chlorine gains 2 electrons. So you add 2 electrons to the left hand side to give you the equation on the slide. That means the charges are balanced. There exists a loss of 2 electrons in the oxidation half, ion 2 to ion 3 plus an electron, and a gain of 2 electrons in the reduction half. So to balance this up, we multiply the oxidation half by 2, making each equation to become as shown on the slide. The next step is to add up the two reactions by cancelling out the common terms, in this case 2 electrons in both halves. The next reaction becomes as shown. The last step is to check if the charges on left and right hand sides are balanced. Looking at the slide, the equation is balanced because on the left hand side and the right hand side we have charges of plus 4. Thank you. So that is all for the ion-electron method of balancing redox equation.